Hello, happy to see you all online. This is Mr. Lin. Today, we will be looking into the implementation of linear regression algorithm. First, we will briefly review the linear regression algorithm. The purpose of the linear regression algorithm is to find the line of best fit for a given group of points. So, the inputs of the algorithm are many pairs of x and y coordinates of a group of points. And the output of the algorithm will be a linear equation of the line of best fit. For example, if the linear equation is represented by the slope-intercept form, such as y equal to mx plus b, the goal of the linear regression algorithm is to find the proper coefficients of m and b of the line of best fit. How do we find those coefficients? Let's follow the steps of the algorithm. Step 1. Start with a random line. In other words, pick random values for the slope m and y-intercept b. Step 2. Pick a large number, for example 1000, as the number of repetitions, iterations, or epochs. It means that we will run through the given point set many times. Step 3. Pick a small number, for example 0.01, as the learning rate. The small learning rate represents the small incremental adjustments of the coefficient of the linear function until we find the line of best fit. Step 4. Randomly pick points from the given data set and adjust the slope m and y-intercept b based on the locations of the points and the learning rate. The locations of points are categorized by either above or below the current line, and the signs of the x-coordinates of the points. This process will be repeated 1000 iterations. Step 5. At the end of the 1000 iterations, the final coefficients will be the coefficients of the line of best fit. With this algorithm in mind, I'm going to warm you up with some C programming notations such that it will be easier for you to learn the linear programming code in the next section. Step 1. Our linear function is represented in the slope-intercept form. Instead of using m and b as variables, we use an array called weight to store our coefficients. So, the linear function can be written as y equal to weight 1 times x plus weight 0. Since we start with a random line, we will get random values of slope, weight 1, and y-intercept, weight 0, by calling a function called random float, and then multiply them by 10. Since the random float function will generate random numbers between 0 and 1 inclusive, our initial coefficient values will be between 0 and 10 inclusive. Step 2. We will define a constant called max underscore iteration with value 1000 as the number of iterations we will run through the dataset. Step 3. We will define a constant called learning underscore rate with value 0.01 as the learning rate. It means that each time we adjust the slope and y-intercept values, we will only increase or decrease by 0.01. Step 4. We use a variable called iteration as a counter in the while loop to count how many iterations we have gone through. When the number of iterations reaches the max underscore iteration, in other words, 1000, we will stop the loop. We will define a constant called NO underscore patterns with value 50 as the number of points in our data sets. Inside the loop, we pick random points 50 times from the given data set to determine their locations in each iteration. The locations of points are determined by two factors. The first factor is whether a point is above or below the current line. It is captured by a variable called output. When output is greater than 0, the point is above the line. When output is less than 0, the point is below the line. The second factor is the sign of the x-coordinate of the point. When xp is greater than 0, the point is to the right of the y-axis. When xp is less than 0, the point is to the left of the y-axis. We use both factors to determine whether to increment or decrement our coefficients of the linear function. Step 5. At end of 1000 iterations, the final coefficients weight 1 and weight 0 will be the coefficients of the line of best fit. Yes, I know it's hard to catch up all these details before you have seen the real code. Now is the time to go through the linear regression code. Since each line of the code has been commented in detail, I will focus on explaining the concepts and logic of the code instead of repeating the comments. Let's start from line 2 to 6. It's a multi-line comment for humans to know the basic info about the code. The computer will ignore it. Line 8 to 10 include 3 header files for various functions we are going to use from the C language library. Line 12 to 14 define constants for learning rate, maximum number of iterations, and number of points in the dataset. Line 16 to 20 is a function called random float to create random floating point numbers between 0 and 1 inclusive. The rand function can generate values from 0 to a huge number 2147483647. And the rand underscore max is a constant with value 2147483647, defined in the header files stdlib.h. That's why when rand function is divided by the rand underscore max, its value will fall within the range of 0 and 1 inclusive. Line 22 to 27 is a function called calculate output to determine whether the point is above or below the line. The values passed into the function include the coefficient weight of the current linear function and the xy coordinates of the points. We then plug the x and y values into the function characterized by the coefficient weight 1 and weight 0 to evaluate the function value sum of the line. If the value of the y coordinates of the point is larger than the sum, the point is above the line. If it is smaller than the sum, the point is below the line. We will return the value 1 to indicate above the line and return value -1 to indicate below the line. Line 30 starts the main function. Line 32 to 35 declare floating points and integer arrays and variables. Line 37 to 41 declare file pointers for input and output files. We open input file data.txt for read and output file output.txt for write. Line 43 to 44 create a for loop to read all 50 pairs of x and y coordinates of data points from the input file and store them in the x and y arrays. Line 46 to 49. The time function in line 46 is a function from the library that will provide you current system time of your computer. Use the output of the time function to feed into the sRand function. We'll create a unique seed for the random number generator rand function. It means that each time you run the main function, you will create a unique sequence of random numbers. You only need to run sRand function once before you call rand function many times in the following code. Line 47 and 48 call the random float function, and then multiply the return value by 10 to create the random coefficients values weight 1 and weight 0. The value of these coefficients will be between 0 and 10 inclusive. Line 49. Just print out the initial linear function based on these random coefficients. After getting the initial random line, we will bring the line closer and closer to all the points in the dataset by incrementally adjusting its coefficients based on the locations of the points relative to the line and the y-axis. Line 51. We run this process 1000 times, so we start by setting a variable called iteration as a counter and initialize its value to 0. Line 53 to 84. Now we enter a while loop that will continue running until the counter value iteration reach the maximum number of iteration 1000. Line 55 to 81. Inside the while loop, we have another for loop that will run 50 times, defined by the constant n__ patterns. Since we have 50 points in the input file data.txt. Line 57 to 59. Line 57 is using the rand function again to generate a random number p between 0 and 49 inclusive. This integer p serves as the index for the coordinates array x and y. In other words, we are going to randomly pick 50 points from our dataset based on p in one iteration. Some points may be picked more than once, and others may not be picked in a specific iteration. However, since we will run 1000 iterations, most of the points will be involved in determining the line of best fit. Line 58 has been commented out. If you uncomment it, the code will not randomly pick points from the dataset anymore. Instead, it will run through every point in the dataset in order in each iteration. It is just for comparison purpose. Line 59 invokes the calculate output function to determine whether the location of the random picked point relative to the current line. The return value of the function is represented by the variable output. If output is greater than 0, the point is above the line. When output is less than 0, the point is below the line. Line 61 to 80. We have an if statement with 4 distinct conditions to update the coefficient array weight. In other words, adjust slope and y-intercept by the learning rate to move the line closer and closer to the points. Line 61 to 65. The first condition. If the point is above the line and right to the y-axis, we will increase the slope and increase the y-intercept. Line 66 to 70. The second condition. If the point is above the line and left to the y-axis, we will decrease the slope and increase the y-intercept. Line 71 to 75. The third condition. If the point is below the line and right to the y-axis, we will decrease the slope and decrease the y-intercept. Lines 76 to 80. The fourth condition. If the point is below the line and left to the y-axis, we will increase the slope and decrease the y-intercept. Line 82 to 83. Once we update the coefficients for every picked point in the dataset in one iteration, we will print out a new function and increment the counter variable iteration by 1. Line 86 to 89. After 1000 iterations, we print out the final function of the line of best fit, close both the input and output files, and end the main.c by returning an integer value 0. Now, let's look into the input dataset file called data.txt. The input file data.txt includes 50 pairs of x and y coordinates of the points. The first element in each row is the x coordinate, while the second element in each row is the y coordinate. The linear regression algorithm is used to find the line of best fit for these points. Once we run the code will automatically write all the output info to a file called output.txt. Let's investigate one of the execution results. The output.txt first shows the initial equation of a randomly picked line. It's the starting point of our algorithm. In each iteration, 50 points are randomly picked from the dataset. Each point is used to adjust the slope and y-intercept of the current line equation. At the end of the iteration, the updated equation is shown in the output.txt. You can see that the slope and y-intercept values are changing incrementally throughout 1000 iterations. More iterations. You can see that the coefficients of the linear equation have gradually stabilized. At the end of the 1000 iterations, we print out the linear equation of the line of best fit based on the values of the last iteration. This is how we use the linear regression algorithm to find the line of best fit of a group of given points in the dataset. Congratulations for finishing up the linear regression implementation lesson. And now you are ready to tackle your assigned project. If you still have any questions, please don't hesitate to contact Mr. Lin. I'm going to see you next time.